Welcome. In this lecture, I'm calling it Becoming Bijective. It's really kind of looking at if a function isn't injective or isn't surjective, what you can do to help it gain those properties. So let's just kind of start out. So here's our first example. So let's take the function, and we're going to take the function f, which is going to go from the, so here's my function, and it's going to go from the integers to the integers. So it starts with Z, I'll remember for a few moments, and goes to Z. Okay, and it's going to be defined by x is going to go to x squared. Okay, and this function is not injective, so f is not injective, so f is not injective. Right. So how do we know that f is not injective? Well, what happens if I apply, so if I have f of 1, then I'm going to output 1, but that's the same thing that I would get if I took f of minus 1. Okay, so two different inputs, right? So the other part being here, but 1 does not equal minus 1. That's just something we know, right? Okay, so it's not injective. I found two numbers that were distinct, but they gave me the same output. It's also not surjective. Okay, so how do I know that? So let's look at the image, or the range, right? So this is equal to, so if I'm looking at all outputs, so this is a subset of here, so this is going to equal, let's give it a different notation, color, because it's actually a subset, and it's going to be important that it is. Okay, so this is actually going to equal, so this is a set of all, right? This is a set of all x squared, such that, so I'm outputting x squared when I inputted an x in my domain, right? So this is my range, right? But this only contains non-negative integers, so it doesn't hit all of the codomain, okay? So this consists of non-negative integers only, so it consists of non-negative integers only, right? So we have that if I take this f of z, I do not actually get the codomain. So this does not equal the codomain. Right, from up there. Okay, but, so here's kind of what this is, what this lecture is all about, which is that, so but changing the domain or codomain, so but changing the domain or codomain can change whether a function is injective or surjective. So whether a function's injective or surjective. So there's hope, and there's ways to kind of change things. Because sometimes you'll start out with a function, but you need a bijection. So you're going to need to alter things until you get a bijection, or at least until it's injective or surjective. So let's, kind of look at these, keep going with these examples. So here's what we're going to do next. So let's take G. So one thing that I could do to make it, if I want to make it injective, so now I'm going to alter my domain and just have it be the natural numbers going to the integers. And it's otherwise the same function, so I'm still sending x to x squared. So this is injective. Right? Because now, so how do we know this? So now, if we have that g of x equals g of y, right, with x and y being natural numbers, right, then we know that right, so then we know that x squared equals y squared. This is like the output. So then we know that x squared equals y squared implies, because, you know, these are both positive, we know that this implies x equals y. Right, and there's something in here about them both being positive, right? Since x, y, and y are both greater than 0. Right. If you have two numbers that are greater than 0 and their squares are the same, then they're the same number, right? We didn't know that in the previous case because we might have had negative numbers. Okay? So it's still not surjective, however. So still not surjective. Right? Since, right, if I take my image, right, like this, I'm still not going to hit any negative integers, okay? Since this contains no negative integers. So this, which I was kind of denoting by orange before, so I'm going to continue that. So this contains no negative integers. Right. Okay. So in particular, so, and maybe I'll even kind of write that in particular. Right, this cannot equal, the image does not equal the codomain. So this does not equal the integers. Okay, so it's not surjective. Okay, well, we can alter it to make it. We made it injective by restricting the domain, and then we can make it surjective by altering the codomain. So we can make, so now we can make G surjective by replacing the codomain with the image. Okay, so for example, so now we could have our function h, reduce the number in my hand. So if now I get my function h is going to go from the natural numbers to, this is, I mean, it feels like cheating, but it totally works, which is that we take the image, the set of all x squared, such that, right, now we're taking all of the outputs that we got from the inputs. And that's it. That works. Okay, so with the same function, of course. So we have x is going to x squared. So this is bijective. Okay. So what is kind of the summary? And I'm going to have to squeeze this on the bottom. So summary. Okay, that's going to be hard to see. I think I'm going to switch over to yellow. Okay, let's just do our summary in yellow. So summary. Okay, so to make injective, what did I need to do? Restrict the domain so that each point's preimage has only one point. Domain, so each point's preimage, or so each element's preimage has only one preimage, sorry, has only one element. Right? And then to make surjective, you replace a codomain with the image. So to make surjective, now we just want to replace a codomain with the image like we did there. Okay, so what went on here? So we started out with a function that was non-injective because two of the distinct inputs had the same output. It also was not surjective because the image or the range was not, it didn't include any non-negative numbers, and so it couldn't be all of the integers. Okay. We could have made it injective by restricting. We knew that every integer and its negative went to the same place, so we just chose one of each of those by restricting to the natural numbers. So that now, if they have the same output, they are the same. Okay, and then we wanted to make it surjective. So to do that, what we did was we took, we just restricted the codomain to be the image. That's kind of the easiest one. And these tricks always work. Okay, so if you want your function to be bijective, you can follow these tricks. So I hope that made some sense and was helpful, and I will see you in the next lecture.